Good morning, students. In this video, today we are going to discuss the higher level MCQs on the chapter Work, Energy and Power. So let us read the first problem. A bullet when fired at a fixed target has its velocity decreased to 50% after penetrating 30 centimeter into it. Assuming that the resistive force on the bullet is constant, the additional thickness it will penetrate before coming to rest is. So try to analyze the situation. The situation will be like this. This is the distance. Let us call this is A and this is B and C. So at A, the velocity of the bullet is V, and when it comes to B, its velocity becomes V by 2. After traveling a distance, they have given 30 centimeter. Let us call it as X, 30 centimeter. After traveling, and resistive force will be in the opposite direction, that we know that. So now after B, at B, it has a velocity V by 2. So with that velocity, what is the distance traveled by it, that we need to find out. That is that, let us call it as Y. That Y we need to calculate here. So very simple, apply the work energy theorem from A to B. Work energy theorem from A to B. So what work energy theorem says? The work done is equal to change in kinetic energy. That is, work done is minus F into X is equal to, so change in kinetic energy is of m into final velocity v by 2 the whole square minus v square. So this is equation 1, and in a similar manner apply the work energy theorem from B to C, that is from B to C. So what will happen? Minus F into Y is equal to, so Y minus, because it is a resistive force, is equal to half m into final velocity at C will be 0, so that is 0 square minus velocity at B will be V by 2 the whole square. Equation 2. Now divide equation 1 by the other, that is we can write x divided by y is equal to, this is equation 1 divided by 2, half m will get cancelled, and simplification of the numerator and denominator we will get minus 3 v square by 4 divided by minus v square by 4 we are going to get. So that is, on simplification we will get 3, that is x by y is equal to 3, or we want y is equal to x by 3. X is 30 centimeter, yes it's 30 centimeter, 30 by 3 will be 10 centimeter is the correct answer, that is A is the correct option. Okay, question number 2. The only force acting on a 8 kg body moving along x-axis varies as shown in figure. The velocity of the body at x is equal to 0 is 1 meter per second. The maximum kinetic energy acquired by the particle is. So very simple, very important thing, my dear students. At 1 meter, at this point, after that, after 1 meter, the velocity, the force goes on becoming negative. Means the force is applied in the opposite direction. See here, in this region, the force is negative. Means force will be applied in the opposite direction. From that time onwards, the velocity goes on decreases. Means at 1 meter only, the velocity is maximum. So therefore, after that the velocity goes on decreases. So that's why first let us calculate the velocity at x is equal to 0. So that is at x is equal to 0. So velocity, let us calculate the velocity. Oh, we know they have given the velocity is 1 meter per second. Let us calculate the kinetic energy. K1 is equal to half mv square. So that is nothing but half into m is 8 kg into v is 1 square, it becomes 4 joule is the kinetic energy at the at O, at x is equal to 0. So then let us imagine, let K2 be the kinetic energy at x is equal to 1 meter. So at this point, K2 is the kinetic energy. Let us imagine that is the kinetic energy. So I think that we need to calculate. So now apply the work energy theorem between x is equal to 0 and x is equal to 1. So what is the work energy theorem says? K2 final kinetic energy minus initial kinetic energy is equal to work done. So K2 minus initial kinetic energy 4 is equal to work done. How do you calculate the work done from here to here? Area below this curve. So how do you calculate the area below the curve? Half into base into height. That is K2 is equal to 4 plus half into, I am bringing this 4 to this side, into base is 1 into height is 4. So it becomes 6 joules is the K2. That's the final kinetic energy. That's the maximum kinetic energy attained at 1 meter for x is equal to 1 meter. Problem number 3. In the situation shown in figure, there is one direct path 1 and other curved path 2. Along direct path, only a conservative force F acts on the particle, means there is no frictional force. Along the curved path, both F and kinetic friction acts on the particle. So through the second path here, two forces are acting. The change in kinetic energy along the direct path is 20 joules and that along the curved path is 16 joule. So the work done by the kinetic friction is. So first take the path 1. This path we will take for path 1. Okay. In this case, we know that there is no other forces. Therefore, I can write change in kinetic energy in the path 1 is equal to work done by the force is equal to 20 joules. This is a known thing for us. Next, for path 2. Path 2. So, change in kinetic energy, work energy theorem. Change in kinetic energy in the second case is equal to work done by the applied force plus work done by the frictional force. Now, I need to find the work done by the frictional force is equal to. So, that is change in kinetic energy 2 minus work done by the applied force. So, change in kinetic energy in the second curved path they have given it 16 minus work done by the applied force is 20 that we have studied in the first case is equal to in the second case. So 16 minus 20 is minus 4 joules is the correct answer. That is option B is the correct one. So problem number 4. A force F is equal to minus k yi plus xj Newton, where k is a positive constant, acts on a particle moving in the xy plane. Starting from the origin, the particle is taken along the positive x-axis to the point A to AO and then parallel to the y-axis to a point AA. The total work done by the force F on the particle is. So first let me plot the graph. That is, this is what the graph we have. Along x-axis, the particle is brought from here to here to the A and then to this point, that is A. So to this point it is brought. What is the work done? We need to calculate. So to calculate that work done, first calculate the work done for x-axis. For x-axis. So W is equal to, or W1 I can call it as. So work done formula is F dot dr, integral of F dot dr. So that is nothing but minus, actually it's minus F dr. Yes, here only minus is there, minus integral of, what is the value of force along x-axis? K into y. K into y into dx. With respect to x-axis we are bringing, but the value of y will be 0 when it is moving along x-axis from O to A. When y becomes 0, W1 is also 0. So that is, in bringing the particle from origin to A, the work done will be 0. Next, calculate for, not for y-axis, parallel to y-axis. Y-axis. That means to move from here to here. So let us calculate by the same method, that is W2 is equal to, as usual the same formula, F dot dr. So F is along y-axis we are bringing, means k into x we need to consider. That is minus integral from O to A. That is from O to A we are bringing. So that is k x into dx, dy, along y-axis we are bringing dy. So here k x is equal to 1, sorry not 1, a. X is equal to a is the value here. So therefore just substitute and integrate. After integration we will get the value of W2 as k as it is, x square by 2, sorry, with respect to dy, no, y it becomes, already a is there. So a into dy, in place of dy also we have, okay, I will do that, minus k a. Integration of dy is y. So apply the limits from 0 to a. In place of y we have to substitute a into a square, that is minus k a square. This is W2. So now what is the total work done? So here I will do that. What is the total work done? W is equal to W1 plus W2. So W1 is 0, W2 is minus K A square. So minus K A square, that is C is the correct option for question number 4. Okay, next question number 5. A engine pumps water